Alright, this is Mr. Gilman. Today we're going to talk about the area of composite shapes. So yesterday we learned about the area of circles and circumference of circles. Today we're going to look at some composite figures, meaning shapes that are made up of more than one other shape. Alright, so before we do anything, we're going to do a little brain dump here. We're going to think about all the things that we know about these shapes here. Okay, the perimeter. Let's start with that. Perimeter is the distance around. And I'm going to underline distance because that's the key word there. So for a circle, we call it circumference. And we know that there's two formulas that we could use for circumference, pi times diameter or 2 pi r, 2 times pi times radius. Okay, I'm going to highlight the part that we're talking about. The circumference is outside. All right, area of a rectangle. Let's talk about that guy. Area of a rectangle is length times width, or you can think of it as base times height. So the area of a rectangle is times width or base times height. When I talk about area, I'm talking about the inside. The area of a circle is pi r squared, or pi times radius. And again, that's the inside. And the area of a triangle is the base times the height, just like a rectangle, but you're going to divide it by 2. Base times height divided by 2. Okay. Now in a triangle, I do want to make a few points here real quick. The base is the side that it lays flat on, but the height is the vertical height. So the straight up and down. So this side on the left, this side on the right would not be considered the height. It's the actual height. Okay. And a composite figure is made up of one or more shapes. Okay, and to find the area, you change the composites into areas you know, and then you add all the areas together. All right, you add them up. You know, the goal is to add a bunch of little shapes together to find the area of a big shape. So let's take a look at a few examples here. In this composite figure, sometimes it might just give you the outside, and you would have to break it into parts on your own. So if they give you just a little outside shape that look like that, like a home plate, you would be responsible to make the dashed line there, and you'd have a triangle and a rectangle. Well, luckily they give you a little information about the triangle that this is 6 meters. So let's find the area of the rectangle first. It looks to me like length times width would be 9 times 7, 63 meters, and that is the area of the rectangle there. The area of the triangle, we haven't done too much of this, is the base times the height, all divided by 2. Well, if you look at this, we need this whole length down here in order to find the area of this triangle. And so I know that if this is 9 centimeters, then this is 9 centimeters. Sorry, meters. So I have a base of 9 and the height of 6. I want to say the area of the triangle is 9 times 6, all divided by 2. In this case, that's 54 over 2, which equals 27. So I have an area in the top of 63 for the rectangle, and on the bottom I have an area of 27. So together, the areas together make a total area of 90. So the area of this entire shape, even though it's a funny looking shape, we can separate it into smaller shapes to find the total area. Okay? That's not what I wanted. That's better. Okay, so let's take a look at the next one here, and I'll change my color here so we can keep our numbers separate. Now, they're likely just going to give you the outside edges right here. And you'll have to draw in the pieces. What we have here is we're finding the area, so remember, looks like I have a 2 by 4 yard rectangle. And I know this length is 4 yards because this length is 4 yards. And so together we have an 8 yard squared rectangle. We've done that before plenty of times. However, this half circle is tricky. We need to find the area of a whole circle and then divide it by 2. So if it was the area of the full circle, it would be pi times radius, or pi r squared. So I'm going to say the area of a full circle would be If this whole length is 4, then its radius would be 2 yards. So I'm going to say is pi times 2 times 2. The area equals 4 pi. All right. So if the whole area is 4 pi of a whole circle, we only want half of that. We're going to divide that by 2. So the area equals 2 pi. So total, we have a total area of the 8 plus the 2 pi. So I'm just going to say my area is 8 plus 2 pi yards squared. Okay. Oops. All right. So that's it, 8 plus 2 pi yards squared. Now if it asks you to round to the nearest tenth, you would of course multiply 2 times 3.14 and then add it to 8. But for video purposes, we're going to leave it like that in terms of pi. Let's take a look at the next one here. Again, we have a composite shape and it looks like it's been divided into parts for us. We got a rectangle here, so I'm going to start with that rectangle. 10 by 10, that makes 100 for my area. 100 square millimeters. And it looks to me like I have a half a circle up here and a half a circle down here. So even though I'm finding the area of a half circle on the top and the bottom, if I have it twice, there's no need for me to divide it by 2. I technically have a whole circle between these two parts. All right, so we're going to find the area of that circle, pi r squared. And so the area would be pi times. Now, if my whole length is 10, then half the length for my radius would be 5. I'm going to say times 5 squared. So in this case, the area would be 25 pi divided by 2 for this one, divided by 2 for this one, but really since we have a whole circle together, I'm not going to divide either one by 2. I'm just going to say that the area between these two is 25 pi. So together, the area of the circle is 25 pi, and I also have the area of the rectangle in the middle. That is units millimeters squared. Now, if they asked you to write it to the nearest tenth or something like that, you would have to take 25 times 3.14, 78 point something probably, 76 point something, and add it to 100, and then you'd have your actual number. But for now, in terms of pi, is just fine. Sometimes they give you a composite figure, and there's part of it missing, and you only want to find the shaded region. So to do this, you're going to find the area of the figures, and then you're going to subtract the parts that you don't want. Okay. So as you can see, there's some shaded part here, all the shaded part, and there's some blank space that we don't want. So what I'm going to do is I'm going to find the area of the entire rectangle, including the blank space for now. The whole thing. And I know that's, looks like it's a 13 by 8 rectangle. So 13 times 8, 104. So the area of the entire thing is 104 meters squared. But there's part of it that I don't want. The part I don't want is a triangle. And so to find the area of a triangle, I know I need the base times the height, and I need to divide it by 2. Well, one thing that I do know is that the height is 6. This length is 6, so that's good. So let's start working my formula here. Times 6 divided by 2. Now I need to know what the base is, which is just from here to here. So to find that, what I know is the entire thing is 13, and this entire thing is 13. If I've got 4 of it used here, that leaves me with 9 left for this part. But 4 of it's being used here, that leaves me with only 5 left for this part in between, for the base to be of the triangle. 4 plus 5 plus 4 is 13. The whole length is 13. So I know the base is 5. And so I have 30 over 2, which is 15. So I have 15 meters squared for the area of the rectangle. Now, keep in mind what we're trying to do. We don't want the area of the rectangle, or the area of the triangle included. We have the entire area, including the rectangle, but we're going to take out the triangle because that's not part of the part we're trying to find. And subtract 15 meters squared from that. So that leaves us with 89 meters squared. Okay, we found the area of the whole thing, and then we subtracted the parts we didn't want, which was all that. And that left us with the area we were looking for. Again, we had this composite shape with gaps in it. So what I'm going to do is I'm going to do a little dashed line here across there. I'm going to find the area of the whole thing, including the gap. 15 times 8, 120. Okay, so I know the whole thing, all of it, including the gap, is 120 feet squared. 120 square feet, I should say. 120 square feet, including the gap. I don't want this gap, though. I don't want this rectangle's worth of area. So it looks like I have a 5 by 3 here. Oops. I got a 5 foot. 5 foot by 3 foot. And so what I don't want is 15 feet squared. I don't want to include that in my total area. I'm going to take that 120, I'm going to subtract the 15, and that leaves me with 105 square feet. Okay, so, ooh, fun one, circle. This circle here, this is going to be a tricky one. This circle is what we call inscribed. This radius, and 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 all the radiuses in the circle, no matter where they're drawn at, they're all the same length, and that's what makes it a circle. Any radius on that thing, no matter where I draw it. So that tells me also that if I draw it straight across, and it goes all the way to the edge, that's 2 inches. If I draw it all the way across here, that's 2 inches. So I can figure out that really the length of this square here is 4 inches. And I can do the same thing straight up and down. If I went straight up to the top, that's 2 inches. If I went straight down to the bottom, that's 2 inches. So really the height is 4 inches as well. All right, so that's going to be important to me because I need to know what the area of the whole thing is before I can figure out the area of just the shaded region. I'm going to start by finding the area of the entire rectangle. And I know that's 16 inches squared. 4 times 4. All right, but I got to subtract out the circle part that I don't want. Luckily, we already know the radius of the circle. The radius of the circle is 2, and we know the area of a circle is pi r squared. So if the radius is 2, I know that the area must equal 4 pi. So I can take away the area that I don't want, leaving me with the area of the gap. Or sorry, the area of the shaded region. So I got the whole area. I took away this part that I don't want. That left me with the area just for the shaded parts. So I'm going to say 16 minus 4 pi inches, square inches as the radius. And like I said, if it says on your worksheet that you need to have to the nearest tenth, something like that, make sure you take 3.14 times the 4 and then you subtract it like that. Okay? That's it for today. Composite figures.